Hi everyone, what's up? Welcome back to my tutorial channel. Today we are going to work on section 7-3, the core level from the IFM Practice exam. So let's look at the first problem. You budget a share of XYZ Corporation at $25 and it has now increased to $45. You're given the effective annual risk-free interest rate is 5%. The price for a 3-month call option with an exercise price of $35 is $13. XYZ does not pay dividends and you want to lock in a sale price of at least $35 for the next 3 months. What is the cost of the option that achieves this result? So here we are given a call option price and we want to lock into a sale price of at least $35 for the next 3 months. So we have to establish a put option where there's strike 35 and duration 3 months. And so in order to evaluate the cost of establishing such put option, we have to use put call parity because the question gives you the call price option. Here C3514 is the price of a call option with exercise price of 35 and duration 14. P3514 is the price of a put option with the same strike and duration. Using put call parity, it should be equal to the current stock price 45 subtract the present value of the dividend. The dividend subtract the present value of the strike. 35 is a strike. And here the question gives you the effective annual risk-free interest rate, not the continuously compounded interest rate. So we have to use 1 plus 0.05 to the negative 1/4 to find the present value of the strike. And that gives a 10.42. Call option is given. So put option here is 13 minus 10.42 and we got 2.58 for the price of the put option because the call option is 13. So the answer here is 2.59. The cost of the option that achieves this result is 2.58. Problem 2. Currently stock ABC trading for $50 per share. The price of a 2-year European call option on the stock and the price of a 2-year European put option on the stock, both with the strike prices of 52.5, are both equal to 8. Stock ABC pays dividends continuously at an annual rate of 5%. Calculate the annual continuously compounded risk-free interest rate. So here we have the price of the call option and the price of the put option with the same strike and duration are equal, which means the difference between them is 0. So we can use put call parity. We got C52.52 represent for the call price, the price of a call option with the strike 52.5 and duration 2 years. P52.52 represent the price of a put option with a strike 52.5 and duration is 2. Now using put call parity, we got is equal to 50 times e to the negative 0.05 times 2 minus 52.5 e to the minus r times 2, because here ABC pays dividends continuously at the annual rate 5%. So we got 50 times e to the negative 0.5 times 2 here represent for the current stock price and also the dividend, the present value of the dividends. And we got 52.5 e to the negative r times 2 here represent for the present value of the strike. So from here we got 0 on the right hand side because call option and price option in this situation have the same price. So the difference is 0. And we have a new equation. 0 is equal to 45.24 minus 52.5 e to the negative 2r. And we solve for R, so your R is negative 1/2. Natural log of 45.24 over 52.5. We got 7.44% is the annual continuously compounded risk-free interest rate. Problem 3, you are given the following. The current price to buy one share of XYZ stock is 500. The stock does not pay dividends. The continuously compounded risk-free interest rate is 6%. A European call option on one share of XYZ stock with a strike price of K that expires in 1 year costs 66.59. A European put option on one share of XYZ stock with a strike price of K that expires in 1 year costs 18.64. Using put call parity, calculate the strike price K. So for this problem, it's already give us the direction. We have to use put call parity. So let's use put call parity. We got CK1 represent the price of a call option with a strike K and duration 1 year. And PK1 is the price of a put option with a same strike and duration 1 year. This difference is equal to 500, which is the current stock price, minus the present value of the strike. Here the interest is given in the form continuously compounded risk-free interest rate. So we got e to the negative 0.06 times 1 to find the present value of the K. Here 1 year, so we don't have to write times 1. Now we got the call price is 66.59, the put price is 18.64. 500 is given as the stock price currently, and K times e to the negative 0.06 is the present value of the strike. Now we have an equation of K. This is just a linear equation of one variable. So we can solve for K. We got K is 480. This is a very simple equation. So the strike price here is 480. Now problem 4, consider a European call option and a European put option on a non-dividend paying stock. You are given the current price of the stock is 60. The call option currently sells for 0.15 more than the put option. Both the call option and put option will expire in 4 years. Both the call option and put option have the strike price of 70. Calculate R, the continuously compounded risk-free interest rate. So again, basically the section is all about put call parity. So using put call parity, we got C74 minus P74. That is the difference between the price of a call option and the put option with the same strike 70 and duration 4 years. This difference is equal to the current stock price 60 minus the present value of the strike. Here we are given the continuously compounded risk-free interest rate is notated as R. So I got e to the negative 4R in order to find the present value of 70. And go ahead, plug the number of 0.15 in the difference. We got 0.15 is equal to 60 minus 70 e to the negative 4R. And from here we got 59.85 is equal to 70 e to the negative 4R. And R is negative 0.4 natural log of 59.85 over 70, which is 3.92%. Problem 5. On April 30th, 2017, a common stock is priced at 52. You're given the following. Dividends of equal amount will be paid on June 30th, 2017 and September 30th, 2017. A European call option on a stock with a strike price of 50 expiring in 6 months sell for 4.5. A European put option on a stock with strike price of 50 expiring in 6 months sells for 2.45. The continuously compounded risk-free interest rate is 6%. Calculate the amount of its dividend. Alright, so again we have to use put call parity, but here in order to find the present value of the dividend, we have discrete dividend. but we're not given the effective annual interest rate. So we have to go and find the annual effective interest rate. So let's call I is the annual effective interest rate. Then we have to make connection between I and the compounded risk-free interest rate 6%. We got 1 plus I is equal to e to the 0.06. This is basic IFM maxim. So from here we got I should be equal to 0.0618, which is around 6.18%. Now we can find the prepaid forward price of the stock with discrete dividend. We got prepaid forward price from time 0 to time 0.5 is equal to S0 minus the present value of the dividend. The current stock price is 52. Let's say X is the amount of its dividend. So the present value of the first amount is X times 1.0618 to the negative 2 over 12. And the present value of the second dividend is 1.0618 to the negative 5 over 12. We got this equal to 52 minus 1.97x. And using put call parity, we got the difference between call price and put price is equal to the prepaid forward price of the stock with discrete dividend minus the present value of the strike. So we got 52 minus 1.97x minus 50 times e to the negative 0.06 over 2. And from here we got x is 0.73. So on June 30th, 2017, a dividend of 0.73 is paid, and the same is paid on September 30th, 2017. Alright, so that's it for today. Thanks so much for watching. I hope you guys like and enjoy my video. See you on the next video. Bye bye.